Alright, this video is for exam 3, page 2, section 1, and we'll start right now. Number 1, use linear approximation L of x to approximate the function f of x with an appropriate value of a to estimate the given number, root 24.9. So we're going to try to estimate 24.9. And the easiest way to do that is get the closest number where this can be an easy way to solve for for root. So our given function is root x because that is what our equation is. F of x equals root x. The closest number to 24.9 that we can easily calculate is 25. So we'll put let a equal 25. A being the number that we're going to approximate for. And what we also need is f prime of x. So f prime of x in this case is derivative of root x, which is going to be 1 over 2 root x. And now what we need to do is solve for f of 25 and f prime of 25. So f prime of 25 equals root 25 equals 5. And we'll do the same for f prime of 25 equals 1 over 2 root 25 equals 1 over 2 times 5 equals 1 over 10. And so now we are going to use the approximation equation, which is going to be L of 24.9 approximately equals to 5 plus 1 over 10 times the original number, which is 4.9 minus a, which in this case is 25, the number we're approximated to. And now we solve for this. So this will equal, move it over here, so will equal to around 5 plus 1 over 10 times negative 0.1, which approximately equals to 5 minus 1 over 100. Once we multiply this, we're going to turn this 5 into a fraction, to 500 over 1. So we're going to have 500 over 100, not 500 over 1, 500 over 100, minus 1 over 100. And so our answer for L of 24.9 is approximately equal to 499 over 100, which approximately equals root 24.9. Alright, now for the next question. So this next question asks, if f of x equals 4x to the power of 3 plus 6x to the power of 2 minus 1, find the absolute maximum and minimum value of f of x on the interval -1 to 1. So our first step is to find f prime of x, because that will tell us when the graph stops increasing and decreasing, and so we will get either our maximum, minimums, or slope asymptote. And so f prime of x equals 12x squared plus 12x. And now we find our zero, our when y equals 0. So the easiest way to do this is that we take out an x from both of these. So x times 12x plus, right, plus 12. And so now we will find when this equals 0. So right here we can see that when x equals 0, the entire equation will equal 0. So x will equal 0. And now we need to find when 12x plus 12 equals 0. So 12x equals -12, and so x will equal -1. Alright, now these two are points that we are given, that we know have to that the graph is no longer increasing nor decreasing. However, what we also need to check is the endpoints of the intervals, because that is also when our graph stops and starts. And so we also need to check -1 in this case, because it's at the endpoint. The x equal 1. -1 we already have, but we would have had to include it otherwise. And this just makes just double check that we do have that our slope does equal 0 at x equals -1. So we're going to need to find f of -1, f of 0, and finally f of 1. So we plug in these values for each one of these equations. 4 times -1 to the power 3 plus 6 times -1 to the power of 2 minus 1. So let's see, -4 plus 6. Oops, that looks like an X. Let me rewrite that. 6 minus 1 equals -1. 1. And so we do the same for the rest of them. See, 3 plus 0 squared minus equals 0. 0 plus 1 equals -1. And now we're finally going to do f of 1, which is 1/3 plus 6, 1 squared minus 1 equals 4 plus 6 minus 1 equals 9. So as we can see, our largest y value is at x equals 1, which is 9, and our smallest value is at f equals 0, which is -1. So we will say that absolute max at 1, 9 and absolute Not good with spelling, sorry about that. At 0, comma, -1. And that is our answer for this page. Thank you very much, and I will see you, well, when I see you. Bye-bye.